Hey guys, last night's video messed up. Actually, it wasn't the video, it was Delta Math froze on me, so I just stopped where we were. And what we're going to do today is we're going to pick up where we left off last night. So I'm going to take us back. Oh, well, I guess I need to present first. All right, let's hide that. All right, let's go back to Delta Math. This is where we were yesterday. This constant of proportionality from context. We only got through one problem. We had the answer correct yesterday, but I'm going to go ahead and show you another one. And here's how I think you should use the video from last night and today. As I'm going through these problems on assignment 6, each time I cover a section, you should pause the video and go to Delta Math. You can open another screen on your computer or whatever, pause your video, and then go and do the problems that have to do with the section that we just covered. Don't forget that you'll need to go back and you'll need to watch the videos that I put on here for you guys, just to kind of reinforce what we're doing. But I'm not going to play the videos while I'm trying to show you how to do these things. All right, so constant of proportionality from context. Nathan practices the piano 1,316 minutes in 4 weeks. At what rate did she practice in minutes per day? All right. Now, first of all, we've got these minutes in weeks. But what we have to do is we have to, first of all, find out how many days that is. So if we're going to say 4 weeks equals how many days? Well, there's 7 days in a week. So 7 days times 4 weeks, that's 28 days where she practices 1,316 minutes. And we want to know per day how much she practices per one day. So we're going to take these number of minutes that she practices, because 4 weeks is equal to 28 days. And we're going to take this number and divide it by the number of days, which is 28. So let's get our handy dandy calculator. I'm going to use a different one this time because I don't know if maybe the calculator on that last time didn't mess us up. All right, so we have 1,316 minutes, and we want to divide that by, we said they want to know per day, so 4 weeks at 7 days a week, that's 28 days, divided by 28. So it looks to me like it is 47 minutes per day. Let's check and see, and let's hope that it submits this time. There we go. I'm going to go ahead and do another problem with you. It says the table below shows the cost of downloading songs from a website. What is the constant of proportionality between the total cost and the number of songs? So we want to know how much it costs per song. So our song is what we want to set equal to 1. So what we're going to do, if you were to work these out, because this is a proportion, it would not matter which one of these you use to do your division. You could say $13.91 divided by 13. You could say $16.05 divided by 15, or you could say $18.19 divided by 17. And I'm going to show you that here in just a second. All right, so here's our calculator. Let's clear it out from our last problem. And we have $13.91. $13.91 divided by 13. And it looks like it's about $1.07. So let's put that in here, 1.07. And then let's check it with the others and make sure that we're right. $16.05 divided by 15. $1.07. All right, so far so good. Let's check the last one. $18.19 divided by 17. $1.07. So let's submit our answer. Say yes. Now you don't have to do all 3 of them. Okay. This is the correct answer. We know it is the correct answer. But what I'm going to do is I am going to go back to another problem. There we go. Oh, okay. There it is. It decided to submit it. So it is $1.07. All right. And we did it right. I'm not sure what's happening with my Delta math here, but that's okay. Like I said, you're going to want to you're finding your one thing and they wanted to know per song. So you're dividing these out and you can find the same one for each pair. I'm going to go back out of this section and now is a good time for you to pause the video and go work your 5 problems for a constant of proportionality from context. And then when you are ready, come back and then I'm going to go ahead and cover the next section. So pause it now and come back when you're ready. All right, here we go with the next section. This is comparing rate of change in proportional relationships. It says 2 friends, Christian and Austin, had just bought their first cars. The graph below represents the number of miles in Y that Christian can drive his car for every X. This is X gallons of gas. So we got miles driven and gallons of gas. The table below represents the number of miles in Y that Austin can drive his car for every X. So this is Christian's gas mileage. This is Austin's gas mileage. Now they want to know how much farther can Austin's car travel on 1 gallon of gas than Christian's car. So that means you're going to have to find 2 rates. You're going to have to find out how many miles per gallon his car gets, and you're going to have to find out how many miles per gallon his car gets. So let's do Christians first. All right. I honestly was kind of confused when I looked at this. This is not 10,272, and this is not 5,136. This is a point. This is the point 5 and 136. This is the point 10 and 272. So don't let that fool you. This is your X and this is your Y. This is your X, this is your Y. So don't let that confuse you when you see a graph like this. All right, the easiest one I see is right here. If he can go 272 miles on 10 gallons of gas, that's going to come out to 27.2. But I'll go ahead and do it for you here. So 272 divided by 10, 27.2. If you want to check it, you can do the 136 divided by 5, but we're not going to do that because I'm going to tell you it's definitely 27.2. So we're going to remember 27.2. And if you want to make a little note of it down here, we know that Christians is 27.2, and then we'll figure out Austin's, and then we'll go back and fix that. All right, so Austin's car can go 234.5 miles on 7 gallons. It can go 301.5 on 9. And it really doesn't matter which one of these you pick. You will find out how many miles per gallon they can get by just dividing one of these out. So let's say that there's 234.5 divided by 7. All right, so Austin's car gets 33.5 miles per gallon. Christian's gets 27.2. So in order to find out how much further Austin's car can go, we're just going to subtract. So we're going to say 33.5. We're going to use this number right here because that's Austin's miles per gallon. And then we're going to subtract 27.2. And that's going to give us 6.3. So he gets 6.3 more miles per gallon than Christian's car. So let's submit it. Okay, so it's going to play games with me again. I am so not sure why it is doing this. All right, let's go back. Let's go do another one. All right, comparing rates of change, proportional relationships. Here, again, remember that this is not a comma right there to denote place value. This is an X, which is 5, and a Y, which is 4,000, and an X, which is 10, and a Y, which is 8,000. All right. And then again, we have our hours and miles right here in a chart form for Explorer B. We want to know how much faster does Space Explorer B travel per hour than Space Explorer A. Well, Space Explorer A goes 8,000 miles in 10 hours. So that would be 8,000 divided by 10. So it goes 800 miles per hour. That's pretty fast. 800 miles per hour. I think we remember 800, but we'll type it down here just so we can see it. 800. No, that's a 600. I'm sorry. 800. So we can see that. All right, now let's go back to our calculator and let's find out how fast Space Explorer B goes. And it does not matter which one of these we divide, they should all be the same. So we're going to say 50,600 divided by 11. And it goes 4,600 miles per hour. Well, that's how fast this one goes. And so let's subtract off our 800. And it goes 3,800 miles per hour faster. So 3,800. Why is it doing this? No, 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 no. How much faster? All right, 3,800. Why do they want us to put it on the chart here? Okay, I am not exactly sure what they're doing here, except how much faster does Space Explorer B traveling to Space Explorer A? All right, if we were to put it on a chart in 1 hour, which would be our X, right? X is hours. In 1 hour, it would be how much faster? Okay, would be 3,800. Wasn't that right? 3,800, yes. I do not understand what is going on with this. No. All right. I think what I'm going to do is I'm going to go back and I'm going to look at Delta Math because it keeps doing really weird things on this assignment. And I am going to reevaluate whether or not we're even going to do this. It's making a mess of things. So we may just take a pause on this, which is what I think we're going to do. Work what you can of assignment 6. I'm going to go back and I'm going to take a look at it because I don't like what it's doing, not submitting answers and changing the way midstream how it wants you to submit an answer. I'm not really comfortable with these problems. And so I think I'm going to come up with a different way. So what we're going to do instead, work what you can, watch the videos, do what you can, that's fine. But what we're going to do is we're going to go back and we're going to skip over that assignment 6 if you need to, and we're going to work on the ratios and proportions workbook 2. I do not like what this assignment is doing. I'm going to go back and mess with Delta Math and see if there's something I can do to fix it. So if you don't get this part done, don't worry about it. This ratio and proportions workbook 2 is where we're going to pick up. So we're going to take a look at this assignment. Remember that you log in with your, you're going to log in with your school address. All right. First of all, we want to know, this again is practicing equivalent ratios. We've done this before, and there's lots of practice on the equivalent ratios, and we need to know if they are equivalent or not. Right here we have 1/4. We have 1/4 and 3/20. And remember, if they're equivalent, you can cross multiply. You can say 4 times 3 and 1 times 20, and you should have the same answer. Well, let's see. 4 times 3 is 12. 1 times 20 is 20. Those are not the same if you're cross multiplying. So then these two ratios are not equivalent. So we're going to say no. Let's look at 3/5 and 12/25. Well, if we cross multiply 3 times 25, that's 75. And 5 times 12 is 60. So 60 is not the same as 75. So these ratios are not equivalent. All right. Let's look at this one right here. 4 times 10 gives us 40. 2 times 16 gives us 32. Well, 40 and 32 are not the same thing. So no, that's not equivalent. All right. Let's take a look at this one right here. All right, we have 3/5 and 15/25. Well, 5 times 15 is 75. If you need to, you can use a calculator to figure that out. 15 times 5 is 75, okay? And 3 times 25, you know that 3/4 is 75 cents. So 3 times 25 is 75, 5 times 15 is 75. If those are both the same number, which they are, that means this is an equivalent ratio. Now, you have more of these to do down here. Again, you can cross multiply. Now, remember that the chart I gave you, I'm going to go back to your Google Classroom just for a second. The chart that I gave you right here, this ratios and proportions chart, all right, this says that, let me pull that up for you. I think it's my internet that's working slow. Let's do it again. All right. This says that a ratio compares two values, but a proportion says that two ratios are equal. And we just worked a whole bunch of problems showing you how to decide if they are equivalent. So now let's go back. Now, in order to form a proportion, these have to be equal. So for them to be equal, you have to be able to cross multiply, make your little butterfly, and come out with the same answer. Well, let's check this one. 3 times 6, that's 18. 2 times 9 is also 18. So that means that the two numbers are the same, which means that these are equivalent ratios. And if they are equivalent, they make a proportion. So that would be yes. Let's look at this one. 1 times 4 is 4. 2 times 2 is 4. All right, so we get the same number when we cross multiply. That means that these two are equivalent. And if they are equivalent, that makes them a proportion. Let's look at this one. Let's look at this one right here. All right, if we cross multiply 3 times 8, that's 24. If we cross multiply 4 times 9, that's 36. So you'd have 36 and 24. Those two numbers are not the same. That means that these are not equivalent ratios. And if they are not equivalent, they do not form a proportion. So our answer is no. All right. Again, same kind of practice on this part right here. And the same kind of practice on this part right here. The only thing different is on these last ones, you have to kind of write out your ratio and proportion so that you see up here, they gave it to you in fraction form. Down here, you're going to have to write it out for yourself. So this would be the same as 3 over 4 and 9 over 12. So if you have 3 over 4 and then 9 over 12, you would be multiplying 3 times 12 and 4 times 9. Well, 3 times 12 is 36. 4 times 9 is 36. So those two numbers are the same. They come out to be the same. Um, if you wrote it out as a fraction, 3 over 4 and then 9 over 12, you would be able to see the 3 times 12 and the 4 times 9. That's 36 both times. So those are equivalent. If they are equivalent, that means they make a proportion. You will need to write these out as fractions. Do the same thing down here. And all you're trying to do is figure out, are they equivalent? And if they are equivalent, they make a proportion. So for today's work, instead of trying to finish assignment 6, I really just want you to work on this ratios and proportions workbook 2. If you haven't done workbook 1, do that. Your video that goes with that is up here. You can start with the November 5th classroom video, then help with Delta Math assignment 5. Here's your ratio and proportions chart, and you can make sure that you can finish this assignment and this assignment, the assignment 5 and the ratios workbook 1. Don't stress over assignment 6. I'm seriously not sure what Delta Math is doing. So what I'm going to do is I'm going to tell you to do what you can of this. I will go back to this assignment today and I will see if I can figure out what my Delta Math is doing, but it's not submitting answers. It's doing some really crazy stuff. So I don't want you getting confused. So skip assignment 6. Work on assignment 5, ratios workbook 1, and ratios workbook 2. If we get back to assignment 6, we will do that later this week after I figure out what Delta Math is doing to it. All right. I really miss you guys. I hope that you are doing well and everybody's staying healthy. I will post this video. It should be up close to 8 o'clock for class to start. And remember, there's going to be 2 of them because there's part 1 that I did last night, and this is part 2. So I'm going to post those videos probably right here below or above the ratios and proportions chart. You're going to see a part 1 video, then a part 2. Watch both of them. Do what you can. And I will work on assignment 6 because I'm just really not sure what it's doing. All right, I'm going to stop recording. I'm going to stop presenting. Um, you guys have an awesome day, and I will get back to you. Please make sure that you email me if you need some virtual tutoring. I will do what I can. I will set something up with you as quickly as possible. And you guys have an awesome day.